In this video, we will talk about LAN concepts or the summary of our chapter 12. The concepts of this chapter is the LAN components, LAN WLAN operation, CAPWAP operation, then channel management, LAN threats, secure WLANs. Then let's talk about benefits of wireless. A wireless LAN or WLAN is a type of wireless network. This is commonly used in homes, offices, and campus environments. Networks must support people who are on the move. People connect using computers, laptops, tablets, and smartphones. There are many different network infrastructure that provides network access, such as wired LANs, service provider networks, and cell phone networks, but it's the WLAN that makes mobility possible within the home and business environments. In business, with a wireless infrastructure in place, there can be a cost savings anytime equipment changes, or when relocating an employee within a building, reorganizing equipment or a lab, or moving to temporary locations or project sites. A wireless infrastructure can adapt to rapidly changing needs and technologies. Type of wireless networks. Wireless networks are based on the the I the Institute of Electrical and Electronics Engineers or IEEE standards, and can be classified broadly into four main types: the WFAN, WLAN, WMAN, and last one is the W1. Wireless technologies. Wireless technology is the unlicensed radio spectrum to send and receive data. The unlicensed spectrum is accessible to anyone who has a wireless router and wireless technology in the device they are using. Radio frequencies. All wireless devices operate in the radio waves range and the electromagnetic spectrum (WLAN). Networks operate in the 2.4 GHz frequency band and the 5 GHz band. Wireless LAN devices have transmitter and receivers due to the specific frequencies of the radio waves range as then the WLAN components. Wireless NICs. Wireless deployment requirement a minimum of two devices that have a radio transmitter and a radio receiver tuned to the same radio frequencies. The end devices with wireless NICs and the network device such as wireless router or wireless access point. Wireless home router, the type of infrastructure device that an end device associates and authenticates with wires based on the size and requirement of WLAN. Wireless router is commonly implemented as a small business or residential wireless access device. The wireless router is advertises its wireless services by sending beacons containing its shared service set identifier or what called SSID. Devices wirelessly discover the SSID and attempt to associate and authenticate with it to access the local network and internet. Wireless access points. While range extenders are easy to set up and configure, the best solution would be to install another wireless access points to provide dedicated wireless access to user devices. Wireless clients use their wireless NIC to discover nearby APs or access points, advertising their SSID. Clients then attempt to associate and authenticate with an AP. The WLAN operation. While wireless LANs can accommodate various network topologies, the 802.11 standard identifies two main wireless topology modes: ad hoc mode and infrastructure mode. Then there is tethering is also a mode sometimes used to provide quick wireless access. Then let's talk about the BSS or basic service set that consists of single access point interconnecting all associated wireless clients. Two BSS are shown in some topology. The circles depict the coverage area for the BSS. Then let's talk about extended service set or the ESS. When a single BSS provides sufficient coverage, two or more BSS can be joined through a common distribution system into an ESS. So in an ESS, it is the collaboration of two or more basic service set. Then 802.11 frame structure. Recall that all layer 2 frames consist of header, payload, and frame check sequences section. All 802.11 wireless contains the following fields: frame control, duration, the addresses, and sequence control, payload, and the FCS. Then let's talk about with CSMA with CA. Booleans are half-duplex shared media configurations. Half-duplex means that only one client can transmit or receive at any given moment. Shared media means that wireless clients can all transmit and receive on the same radio channel. This creates a problem because a wireless client cannot hear what it is sending, which makes it impossible to detect a collision. To resolve this problem, the WLANs are used carrier sense multiple access collision avoidance, the CSMA with CA. As the method to determine how and when to send data on the network, wireless client does the following: listen to the channel to see if it decided, then sends a ready to send message. The access point receives a clear to send message from the access point. If the wireless client does not receive the CTS message, it waits a random amount of time before starting the process. After it receives CTS, it transmits the data. All transmissions are acknowledged if a wireless client does not receive an acknowledgement. It assumes a collision occurred and restarts the process. Wireless client and AP association. For wireless devices to communicate over a network, they must first associate with an access point or wireless router. An important part of 802.11 process is discovering a WLAN and subsequently connecting to it. Wireless devices complete the following three-stage process: discover a wireless AP, authenticate with access point, associate with access point. Then the CAPOP operation. CAPOP is an IEEE standard protocol that enables CWS to manage multiple APs and WLANs. CAPOP is also responsible for encapsulation and providing of WLAN client traffic between an AP and a WLC. CAPOP is based on LWAP but adds additional security with Datagram Transport Layer Security, or the DTLS. CAPOP establishes tunnels on user datagram protocol, which is the UDP ports. CAPOP can separate either over IPv4 or IPv6. A key component of CAPOP is the concept of split media access control, or MAC. The CAPOP split MAC concept does all the functions normally performed by individual access points and distribute them between two functional components, which is the AP MAC functions or the WLC MAC functions. Then DTLS encryption. It is a protocol which provides security between the AP and the WLC. It allows them to communicate using encryption and prevents eavesdropping or tampering. Then it is enabled by default to secure the CAPOP control channel, but is disabled by default for the data channel as shown in the CAPOP management and control traffic exchange between an AP and WLC is encrypted and secure by default to provide control plane privacy and prevent man-in-the-middle or MITM attacks. Then let's talk about FlexConnect APS or FlexConnect access points. It is a wireless solution for branch office and remote office deployment. It lets you configure and control access points in branch office from the corporate office through a WAN link without deploying a controller in each office. Then channel management. Wireless LAN devices have transmitter and receivers tuned to specific frequencies of radio waves to communicate. A common practice is for frequency to be allocated as ranges. Such ranges are then split into small ranges called channels. Then, best practice for WLANs requiring multiple access points is to use non-overlapping channels. For example, the 802.11b, G, or N standards operate in 2.4 GHz to 2.5 spectrum. 2.4 GHz band is subdivided into multiple channels. Each channel is allotted 22 MHz or MHz bandwidth and is separated from the next channel by 5 MHz. Data 2.11b standard identifies 11 channels for North America. Number of users supported by WLAN depends on the geographical layout of the facility, including the number of bodies and devices that can fit in space, the data rates users expect, the use of non-overlapping channels by multiple APs in an ESS, and transmit power settings. Then, LAN threats or WLAN threats. A LAN is open to anyone within range of an AP or access point, and the appropriate credentials to associate it with a wireless NIC and knowledge of cracking techniques. An attacker may not have to physically enter the workplace to gain access to WLAN. Then, the secure WLANs. Wireless signals can travel through solid matter such as ceiling, floors, walls, outside of the home or office space without stringent security measures in place. Installing a WLAN can be the equivalent of putting Ethernet ports everywhere, even outside. Then, that concludes the summary of our Chapter 12.